Hey guys, welcome back to my channel. In today's video, we are going to see how to solve this problem called kth smallest prime fraction. Right, so it's a LeetCode problem of the day for today. So let's have a look at this question. An array will be given, let's say ARR 1, 2, 3 and 5, right? And along with that, a k also is given. So k is actually 3 right now. So what I have to return? I have to return the kth smallest prime fraction. What does that mean? This basically means that I have to pick I and j. Those are basically two indices in this array, and I should be coming at first and j should be coming after that, right? And this ARR of I divided by ARR of j, right? This is a fraction. So we have to find all the possible fractions and we just have to sort them, and then we have to give the third smallest value, right? So we have to give the third smallest value, right? But not exactly, because they are not asking for the value, but we have to return the numerator and denominator, right? So in this 2 and 5 will be the answer. So 2 is here and 5 comes after that, 5 is here, right? So these all are the all possible fractions, and this is the kth smallest fraction among all these fractions, right? So let's understand the problem with this example. Let's say 1, 2, 3, 5 is given and k is 3, the same example, right? So 1 by 2, let's take these two. 1 by 2 will give 0.5, and then 1 by 3 will give 0.3, and then again 1 by 5 will give 0.2. So basically what we are doing, we are actually getting all the possible pairs and then getting their fraction, right? Getting their fraction. So after that I will go for 2 and 3, then I will go for 2 and 5, right? Then after that I will go for 3 and 5, right? So 2 and 3, 2 and 5, 3 and 5. Then I got all the fractions. Then what I'm going to do, I'm going to sort them. So after sorting, it will be 0.2, 0.3, 0.4, 0.5, 0.60, and then 0.66. So basically I have to give the kth smallest value, that is the third smallest value in this case, right? So the third smallest is basically this value, right? So 0.4. Is this the answer? I would say not really. Why? Because I don't want 0.4. What I want, 0.4 is the fraction of 2 by 5, right? So I want 2 and 5 as the answer. Okay, so one thing we got to know that we can do this operation and then we can sort them and we can get this value. But we don't want this value. We want these two, right? So somehow we have to attach these two values together. So we have to sort them, but please keep numerator and denominator along with them. Why? Because we need that numerator and denominator as the answer, not the fraction. So what I'm going to do, I'm going to store the fraction and then numerator and denominator along with this fraction, right? Then I'm going to sort according to this, and then after sorting, let's say these all are the elements, so 0, 1, 2, 3, 4. So after sorting, the kth smallest will be in the index k minus 1, right? First smallest is in the index 0, second smallest is in the index 1, third smallest is in the index 2, right? So similarly, I can navigate to the kth smallest and then I will fetch the numerator and denominator, right? So how I am going to implement this? I am going to implement this in a vector of pair. Inside that, I will store the fraction, and then that fraction will be connected to the other pair. The other pair value also will be having a pair that will be the numerator and denominator of this fraction, right? So the approach is pretty simple. So let's have a look at the code, right? So here I am maintaining this vector. Then I am going for all the possible pairs, right? All the possible pairs. And then at a particular pair, I will calculate the fraction, let's say div, and this will have the fraction value, right? Then what I'm going to do, I'm going to push this fraction value along with the numerator and denominator into the vector, right? Then after pushing all these values, I'm going to sort them. So while sorting them, it will be sorted according to the div, right? According to the fraction. So after sorting them using k minus 1th index, I will have the access to the smallest kth pair, right? So this will give the numerator and this will give the denominator, right? So coming to the time and space complexity, For time complexity, of course, we are going to get all the pairs, right? So we are iterating for of n square in this part, and here and log n time is given. So considering the higher degree, I can say the time complexity is of n square, right? So space complexity also, it will go till of n square. Why? Because see, for all these pairs, I'm storing their fraction also, right? So that's the reason space complexity will also be of n square. But can I optimize this? Can we optimize this? I think yes. How? Do we have to store all the n square possible answers to get kth smallest one? I think no. Why? We can make use of heap, right? So how I'm going to approach this? Let's say this is the array 5, 2, 1, 3, 4, and what I'm going to do, I'm going to maintain a max heap, and I'm going to push all these elements in this, right? So 5, 4, 3, 2, 1, these all are the elements, and the top most guy will be the maximum, right? It will be the maximum. So what I'm going to do, I'm going to remove this, remove this. Now k elements are there. So the topmost guy will be the kth smallest guy. Can I say that? Yes. So it's taking basically off and space, right? I'm saying no. We can optimize this also. I will be storing k numbers only. The moment max heap size is greater than k, I will immediately remove that, right? So keep pushing the elements, and if the priority queue size is greater than k, that means there is one element which will not be the answer anyway. So we will just remove the topmost element. Right, so let's have a dry run on this. 5, 2, 1, 3, 4 is given. So what I'm going to do, I'm going to push this. So 5 will come here, and then I'm going to push this. So 2 will come here. So 5 will come here, and then 2 will come here. And I'm going to check whether the size is greater than 3 or not. I think no, because till now we have only 2 elements, right? Then I'm going to push this also. So this 1 will come here, and the size is 3 now. Is this greater than k? No. So I'll push this. Now 3 will come here and 5 will be here, right? So now I have 4 elements, which basically means that we can remove the topmost element, right? Why? Because 5 won't be the answer anyway. So we are going to remove it, and then we are moving forward, right? 4 will sit here. Size is 4 again. So we are going to remove this 4 also. So now max heap has k elements. So pq dot top will be giving the topmost element, right? But we are actually diverting from the actual topic. We don't have to store these elements. We have to store what? We have to store the fraction, right? We have to store the fraction along with their numerator and denominator. So I will do the same thing, but instead of numbers, I'm going to store this thing, right? So let's have a look at the code. I'm going to declare a priority queue, and then I'm going to iterate to get all the possible pairs, and then I will be calculating the fraction. And after that, I'm just going to push this fraction along with the numerator and denominator. And then I will be checking, bro, is the size greater than k? If it is, remove the topmost element. So at the end, kth pair will be sitting at the top. So pq.top.second will be giving the pair where the first value will be the ith value and second value will be the jth value, right? So I will simply return that kth pair dot first will be the numerator and kth pair dot second will be the denominator of that kth pair, right? Basically kth smallest pair, right? So in this time complexity is, of course, it is n square, but space complexity, it reduced from n square to O of k, right? Why O of k? Because at max, it will be having k plus 1 element, and the moment it comes here, I will be removing one element, right? I will be removing the extra element, right? So at max, I can say that O of k will be the extra space that I am taking. So that's it for the video. If you like the video, hit the like button, subscribe to my channel. Until next time, see ya.